Hey guys, how's it going? This is Carl, and this is week 4, problem number 2. We'll go ahead and dive right into it. The question is, assume that the conditions for correlation are met. Is the following statement true or false? If false, please explain. The units of correlation are the same as the units of x. So, off the bat, this statement is false. Why? Because correlation has no units, as we can tell. Correlation treats x and y symmetrically. Correlation of x with y is the same as the correlation of y with x. Correlation is not affected by changes in the center or scale of either variable. But as a review, we're going to go over the conditions of correlation also, just to kind of make sure that we all are on the same page. Part of it is the quantitative variables condition. Correlation applies to only quantitative variables. Don't apply any correlation to categorical data. Camouflage just quantitative. What does that mean? Zip codes, ID numbers, area codes, nothing that's really measurable. And it has it's not, categorical data is just that. It defines a category. Zip codes are a category of a geographic area. So you just have to take that into account. And check the note the variable units and what they measure. It's very key when you're talking about applying or looking to apply a correlation. In addition, straight enough condition, you can calculate a correlation coefficient for any pair of variables, but correlation measures the strength only of the linear association, and it will be misleading if the relationship between those two are not linear. That's a good point to make also. And lastly, the outlier condition. Outliers can greatly distort your data. An outlier can make otherwise small correlation look big or hide a larger correlation. It can even give an otherwise positive association a negative correlation coefficient, and vice versa. And when you see an outlier, it's often a good idea to report the correlations with and without the point. And it's very important when you think about outliers. You know, if you're trying to get, for instance, you're at a restaurant and you're trying to do a statistical study on the tip. What is the average tip? Well, you're doing your scatter plot, your x, y, kind of basing it on the time of day and the amount of tip, for example, y and your x. And someone randomly walks in at a certain point and tips $1,000. Well, that's a very important outlier to note, because if you keep that in there and don't note that, it's going to have your average for that day or that time period, depending on how you're breaking it down, is going to be astronomical. And it's not going to be entirely accurate, because that is in essence an outlier. That is not the normal condition. That is not what is the traditional average observed observations rather. So it's very important to report outliers, because it gives you a better sense of the population, and it gives you a better sense of just kind of the randomness of the outlier condition itself. So, and that kind of does it for this problem, but we hope this helps, and just let us know if you have any questions along the way. Thanks much.